Welcome to your first revision lesson on indices. Today we're going to be looking at all the information that you've learned from your live lesson this week and building that into you getting some practice using indice rules and preparing yourself for the first homework that's due this week. So please make sure that you have pen and paper in your hand. You don't need a calculator for this lesson, you just need to make sure that you've got lots of space to write lots of notes. Following this lesson, I really recommend you write up your notes so that you've got all the key formula and rules that you've been using, along with any key examples that you think are really useful. You will also be able to then go and do your homework or part of your homework. So your homework's set on Hegarty Maths, and by the end of today's lesson, you'll be able to go and do clip 105, 106, and 107. And remember, for a clip to be completed, you must have completed the practice questions and have gotten 90% or more. If you get stuck on anything or you're still unsure about some of the content, it's really important you contact me directly. So drop me an email and I will arrange a time to go through some of the maths with you. Let's get started. So we're going to start by looking at some of the questions that we did in the lesson on Monday. So have a look at these questions. I want you to pause the video and have a go as many as you can. At this stage, I'm not too worried about right or wrong. I just want to see what can you remember from the live lesson on Monday. So pause it now. Welcome back. Now I'm going to give you the answers. So what I'd like you to do is mark your answers. Any questions that you didn't get right, I want you to circle. At the end of the lesson, we're going to come back and have a look at these questions again and see whether we can correct the things that we didn't quite understand. So here are the answers. So number 1A should be V or V to the power of 1. B should be U to the power 8. C should be H to the power 14. D should be N to the power 4. E should be X to the power 10. Question 2, we should get 512, 125, 64, 36, and 49. Right, we're going to start by going back over some of that key content. There's also a few skills checks that I'm going to embed into what we're doing because we're going to be having a look at lots of fractions and lots of negative numbers in today's lesson. So, firstly, index notation. Index notation is so great because it just saves us so much ink. We don't have to write things out in longhand. So 3 to the power of 4 is the same as writing 3 times 3 times 3 times 3, which just takes a lot of time and takes a lot of space. So this is a much nicer way. Please note, this is not the same as 3 times 4. Okay? They're two different things. So 3 times 3 times 3 times 3 is 3 to the power of 4, and 3 times 4 is just 12. Okay? Same here, 7 to the power 0. Just like we said, sometimes that is just written as 7. Okay? So if there's no power there, it means the power is 1. And 6 to the power 5, 6 times 6 times 6 times 6 times 6. I've got 5 6s there. A much, much, much bigger number than 6 times 5, which is 30. So really note the differences. One key rule that I need you to make sure you've written down and learn off by heart. Super common in the exam. Anything to the power of 0, so 9 to the power of 0 is 1. And at this stage, I'm just going to ask you to accept that and believe me, and we're going to go back over, once we've done our dividing indices, I'll show you why that is the case. So 9 to the power of 0 is 1, 64 to the power of 0, 1, 22,465 to the power of 0 is 1, anything to the power of 0 is 1. So key rule there, x to the power of 0, always 1. Doesn't matter what x is. Anything to the power of 0, always 1. Okay, let's also build in some fractions now. So we should all be happy with, if I gave you something like 3 squared, you would say, okay, that's 3 times 3, which is 9, which is nice and easy. Now let's just build in some fractions. So this first question, if I had 7 over 9, somebody was asking me to square it, that would be the same as 7 over 9 times 7 over 9. Skills check here, when you're multiplying fractions, we just multiply across the top, multiply across the bottom. So this would be 7 times 7, which is 49, and 9 times 9, which is 81. I don't need to worry about having the same denominator. All I care about is multiplying 7 and 7 the numerators and multiplying the denominators, 9 and 9, 81. Okay, and that works exactly the same even if you're cubing it. So if I pull D up, I've got 5 over 4 to the power of 3. So that is 5 over 4 times 5 over 4 times 5 over 4. So hopefully that should, again, coming back to an index notation, show you that you can just cube the top number because that's 5 cubed. Cube the bottom number, because 4 times 4 times 4 is 4 cubed. So I'm going to work that out, 125 over 64. Okay, so I'm going to ask you to pause your video again, have a go at these 10 questions. I've done 2 of the questions for you, just making sure that we've got that fraction multiplying down. So if you want a key rule here, it's multiplying fractions. And I like to usually just do those signs to remind me I multiply across the top and multiply across the bottom. So numerator, and then you times the denominators. Okay, and you could pick an example there to have down. So have a go at those 8 questions. Ready to check our answers? So here are the answers. Again, go through them yourselves, mark them yourselves. Pause the video so you can get all these answers in. Questions that you haven't got right, I want you to circle, go back over, have a look, see whether you could spot, was it just a silly error? If it's still outstanding, if you can't work out where you've gone wrong, circle it. When you come to the lesson, you can collect those questions together, put them in an email to me, and we can arrange time to go over them. Second skills check, negative numbers. Now, people think negative numbers is something they do at primary school, they don't look at it again. It is fundamentally what underpins everything we do, and there are so many parts of the GCSE which actually simply come down to, can we manipulate negative numbers? So it's really important. We're going to go over it tons and tons and tons and tons and tons next year. The quicker we can get these rules into our head and be able to use them really confidently, the better. Remember, in your exam, you're stressed. In your exam, you're trying to do your absolute best, and sometimes that pressure can lead us to make really silly errors. So we need foolproof methods that mean that we can be really confident with our fundamentals. So the first thing we're going to look at is negative numbers, and specifically, how do we add and subtract negative numbers when you have 2 operations that are touching each other? So your set rule here is this. If you have a positive number and a positive number touching each other, or a positive and a positive operation touching each other, that results in positive. If you have a negative and a negative operation touching each other, that results in positive as well. Positive and a negative becomes a negative, and a negative and a positive becomes a negative. And the way I remember this is to think about, what does this look like on a face? So the first one, positive and positive, they make your eyes. If you've got matching eyes, they're both positives, that makes you happy. So overall, you are positive. That's why it becomes a positive. If your eyes are like this, they are matching, that makes you happy. Overall, that makes you positive. Here, one eye's blinked, one eye's open, one eye's closed, that makes you unhappy, negative. Okay, same again here, eyes don't match, negative. Okay, so there's your rule for remembering it. Let's have a look at one example, or a couple of examples. Let's get question number 1 to start with. You've got 5 plus negative 3. So 5 plus negative 3, well, you have 2 operations that are touching each other. So we're going to use our rule to get rid of that and simplify our problem. So you've got a plus and a negative touching each other. They don't match, so it becomes an unhappy face. So this question becomes negative, so it becomes 5 minus 3. So you're on your number line, you're at 5, and you're going down another 3. It's still a positive number, stays at 2. Okay, let's do one more. So let's do minus 3 plus 4. So minus 3 plus 4, I'm not going to use this rule for, because there are not 2 operations that are touching each other. I've got a minus 3 and a plus 4, and the minus and the plus in my question are not side by side, they're not touching each other, so I can't use my rule. So instead I just have to work it out, and I have to think to myself, okay, I'm at minus 3 in the number line, and I'm going up 4. So I'm at minus 3, I'm going up 4. So I'm going up 4 from minus 3. The resultant is going to be a positive number. I should end up with a positive 1. Okay, remember, there's absolutely no problem in you putting that number line on there and thinking to yourself, here I am, minus 3, and I'm going up 4. So I'm going to go 1, 2, 3, 4. I'm looking for this number here, and then putting your numbers in to make sure that you've got it right. Okay, so you've got 18 questions to do. I want you to pause. I want you to blitz these questions nice and quickly. Make sure that you've got your negative numbers all sorted. Pause your video now. Okay, welcome back. Let's check answers. So I put the answers on the screen there. So hopefully that's all made complete sense and you're happy with your negative numbers. I've also just put that summary of our rule here. So again, this is our rule for negative addition and subtraction. Right, let's look at how this actually works. So the first rule of indices we've said, remember, x to the power 0, any number to the power 0 is 1. This is our second rule. So this is where we say, okay, if I've got the same base, so x to the power a times x to the power of b will give me x to the power of a plus b. And x doesn't matter, x can be any number as long as you have the same number here and the same number here. So that's our rule. Let's see how that works in principle. So the first thing you've got is 3 to the minus 4 times 3 to the 8. So you've got the same base, you've got a base of 3, which means we're going to add our powers. So straight out, you've got minus 4 add 8. So I'm at minus 4 on the number line and I'm adding 8 to it. So I'm at minus 4, I'm adding 8 to it, I should get to 4. So my final answer here is 3 to the power of 4. And I'm going to point out here, this working out, absolutely fundamental. It's not something we should be doing in our head, and it's not something we should be doing in the corner of our page that no one can get. This is the stuff you want to be showing off to make sure you're absolutely getting the full marks. Let's just have a look at it in the same context, but with algebra. So now I've got y to the power of 2 and y to the power of 13. Absolutely no different method. They're being multiplied together, so that means I add powers. So I'm going to write here 2 add 13, and I get 15. Okay, so final answer, y to the power of 15. Okay, remember this rule only works because y's are both the same. Or my first question, I had a 3 in both cases. If I was given something like 4 to the power of 2 times 6 to the power of 3, there's nothing I can do with that. And the reason I can't do anything with it is because my base are not the same. So I can't use this rule. This rule only works when the bases are the same. Let's have a go at some questions. So I've given you a set of questions here. They should be, again, nice and quick. I want you to pause your video and have a go at these questions. Then we'll go through the answers. Okay, so pause your video now. Right, welcome back. Let's have a look at the answers. So I'm going to go through these very quickly. First one should be 6 to the power of 3 plus 2, which is 5. B should be 5 to the power of 5 plus 7, which is 12. C should be 2 to the power of 7 times 2 to the power of 9. So I'm adding the powers, so 2 to the power of 16. D, 7 to the power of 10. E, let's just have a quick look at E. You've got 9 to the power of 9 times 9. So remember, if it's a number on its own, that implies that the power is 1. So here, this final answer should have been 9 to the power of 10. Next one, 8 to the power of 6. G, 4 to the power of 14. H, 10 to the power of 12. I, 3 to the power of 14. J, 9 to the power of 14. K, 2 to the power of 12. L, 8 to the power of 15. M, 5 to the power of 14. N, 6 to the power of 7. And finally, 4 to the power of 8. Okay, so check those answers. Make sure you're happy with them. Again, if there's something you're not sure about in this case, all we are doing is adding the powers. So if that hasn't worked out, go back to your adding, make sure that's really that's correct. Right, let's build this up. Now we're going to use an algebra. Actually, what we do is we turn it into a really easy one. We split the two up. So this one, I've got to say, this is a really common question from the exam. It's really common to get this wrong because we don't show our working on the page. We try and do it all in our head, and this is why. Let's do all the numbers. So I've got 2 and a 3. So this becomes 2 times 3. So the numbers get times together, and 2 times 3 is 6. Then we do the m's. Now they've got the same base. So I write m to the 3 times n to the 2. So it's a 3 and a 2 again, but this time, because you've got the same base, the powers get added. So this actually becomes m to the power of 5. So my final answer here is 6 m to the power of 5. Okay, let's just quickly look at why that's working. Actually, what's going on between this 2 and this m and this 3 and this m? There's a multiplication there. So if I was to write this out in full, 2 m cubed times 3m squared is the same as 2 times m cubed times 3 times m squared. So they're all being multiplied. And because they're all being multiplied, I could actually write them in any order I want. So I could write the 2 and the front times the m to the power 3 times the m to the power 2. Okay, and then I could do the numbers times numbers, which is where I get 6. And I could do the powers and the powers which get added together, which I get m to the power of 5. So the final answer, 6m to the power of 5. The problem with this method here is because your two things are very close together, you're doing times 2 and 2 add 3. There's more room for error. Whereas if we set up, we're doing on this side of the page numbers and then indices, much clearer setup, much less likely to make an error. So let's have a look at another example. You've got 4k cubed times 3k squared. So deal with the numbers. 4 times 3, 12. Let's deal with the k's. K cubed times k squared, the powers to the power of 5. Final answer, 12k to the power of 5. Okay, that should be nice and easy. You're going to have a go at some questions now. So, nice and straightforward. Some of them get a bit long, but they're absolutely no different. Let me give you a hint for number 9. Okay, again, absolutely no different. You just need to write out all 3 together. Remember, in this case, this h to the power of 6, if there is no number in front of the letter, that means that there is a 1 in front. And sometimes it's much easier to write that one so it can be really clear in your head. So with question number 9, the numbers are 8 times 4 times 1, and the powers of h are h to 7 times h squared times h to 6. So there's your hint there. So pause the video now, have a go at those questions. Welcome back. Let's have a look at some of these answers then. So let me answers for you. Okay, so answers are on the page now, so you should be able to check those. Again, circle anything you didn't get quite right. Pause the video, see if you can get back over and spot what happened. And if not, collect together any other questions and get in contact with me and we can go through it together. Right, next one, rules of indices. We're looking at division now. So division, very, very similar. We're subtracting our powers though. So in this case, if you wanted to have a set rule, my rule would be x to the power of a divided by x to the power of b is the same as x to the power of a minus b. You subtract, okay? And remember, division can look very different. You can write it as a fraction. So this guy here is saying divide. So that thing there is to me that you are dividing. But equally, it might be written out like a division. So it might have been written as x to the power of a, and then you've got the division sign. Okay, absolutely no different to what's going on. It's just been written in a different way. It's still a minus b. This is the case where you have to be really careful with your negatives. Okay, and I'm going to show you why in this first example. So in this first example, you've got 12 to the power of 5 divided by 12 to the minus 2. So you're going to subtract your powers. So I write a subtraction here, and then I write out that subtraction. So you've got 5 minus, and this guy is a minus 2. So you've got actually 2 minuses, and I put the bracket around the minus 2, so it's really clear for you to see you've got 5 minus a minus 2. So you've got 2 minuses there, 2 minuses touching. So we're going right back to the start when we're looking at our core skills. 2 minuses touching, you've got the same eyes. That makes me happy. So it becomes 5 plus 2. So this answer is 7. The final answer here is 12 to the power of 7. 12 to the power of 7. Okay, let's look at one more question. So again, t to the minus 9 divided by t to the 4. So I'm subtracting the powers. Don't do this in your head. Write it out. You've got minus 9. So with that picture, I've got minus 9 minus the 4. And all what's important here, you start with the minus 9 minus the 4. So this time, the signs aren't changing. So they're not going to disappear. They're not going to become a plus. I've got minus 9 and minusing another 4. So I've got minus 9 and I'm going down again another 4. So that means I'm staying negative and I'm getting the negative 13. So final answer here should be t to the minus 13. Okay, you can understand every indice law that there is and fully comprehend it, but if you don't write clearly on your page or use the fundamental subtraction rules, you're not going to get the marks for it. So have a go at some questions yourself. And let's have a go at some a few more challenging ones, like we were just doing with the multiplication, because it's absolutely no different. So same rule applies here. I'm going to do the number divided by the number. So this is 10 divided by 2, giving me a 5. And then I'm going to do my algebra. So I've got p to the power 5 divided by p to the power 3. They're being divided, so I write in the subtraction. Let's actually do that. So subtraction 5 minus 3 is a nice easy one. I should get 2. So this becomes p to the power 2. Final answer, 5 p to the power 2. Similar here. If you want to pause and have a go at yourselves, absolutely do that. Otherwise, I'm going to go through this one if you want to see one more example. I've got 12 divided by 4, which is 3. And then I've got p to the power 8 divided by p to the power 3. So I'm subtracting the powers. I'm going to write it here. 8 minus 3, which is 5. So I get p to the power 5. So final answer, 3 p to the power 5. Right, time to have some of these questions yourselves then. So exactly like I've done those examples, you can whiz back and watch them again. These should be very nice, straightforward questions that are just easing you into how we're doing this topic. So pause now. Welcome back. So we should have some answers to go through. Okay, so you should have the answers now on the screen. There's just a couple that I want to pick out, and in fact, just this one here. So pause your screen if you want to quickly mark them. Otherwise, we're going to have a look at question number 10. So if we look at question number 10, this is a really good example of how we know this rule here. So remember what we said before, x to the power 0 equals 1. Any number to the power of 0 equals 1. And this is the reason why. So you've got, I'm going to write it like a division, like a fraction. So look at this, 40m to the 18 divided by 4m to the 18. Okay. Now, if we just look at these numbers first, hopefully the numbers are nice and easy. So we're happy that that becomes a 10. Now, the more interesting part, m to the 18 divided by m to the 18. So you are dividing a expression by itself. You are dividing m to the 18 by itself, m to the 18. And we should know that any number or any function, any expression divided by itself is 1. So I know, for example, that 6 divided by 6, how many times can I fit 6 things into 6 pots? I can fit 1 into each of them. So 6 divided by 6 is 1. X divided by x in algebra terms is 1. So therefore, m to 18 divided by m to the 18 is 1. But I also know my rule about dividing indices. I also know that 18, to do this division, I have to do 18 minus 18. So this is what implies that m to the 0 must equal 1, because any number divided by itself is 1, but my rules of indices say I can also do 18 minus 18 to get the 0. So this answer here, you could write this as 10m to the power 0, but really you should also recognise that m to the power 0 disappears in terms of 1. So your final answer here is actually just 10. Right. Let's have a look at kind of all of this combined. So what you've got in this now is much more standard exam style questions, kind of building it all together. So I will pick out a few to have a look through. You've got divisions, you've got brackets, and you've got multiplication. So let's do the first row for you. So the first row, the first question you've got is a division. You do exactly the same as what we've been doing. You need to split up what you're answering. So let's just make a bit of space. Here we go. So you have got, for part A, the number divided by the number. So you've got 10 divided by 5. So there's your first mark, 2. Then you've got the t to the power 14 divided by the t to the power 4. They get subtracted. So we should have t to the power 10. And then you've got another term here, which is where it's getting slightly harder. J to the 16 divided by j to the 10. Subtraction, j to the 6. So final answer here should be 2 t to the power 10, j to the power 6. And you can see this method that we've been doing with our simple questions works really well when the questions become harder and longer, because you just do them in exactly the same way. Let's have a look at B, because B is something we've done in our live lesson, but we haven't looked at yet. We've got the bracket rule. Now, this rule is really, really, again, important how we set it up, because what's really common is to use this 2 here and apply it to the 3, but forget to apply it to here and forget to apply it to here. So this 2, to be able to use it, it needs to go into each of these terms. So when I split it up, just like I've been doing before, I would write this as 3 squared. Okay, well that's 9, it's 3 times 3. Then I've got x to the 9 squared. Well, inside and outside our bracket, hopefully you can remember, inside and outside the brackets, it gets multiplied. So this is x to the 18. And then finally, you've got w on it, which is the same as w to the power 1 to the power 2, which becomes w to the power 2. So the answer here is 9 x to the 18 w to the power 2. Okay, and let's just finish by doing one multiplication. So we're going to split it up. So for part C, you would do 3 times 4, which is 12. You would do p squared times p, which will make p to the power 1, so become p to the power 3. And you've got s to the power 10 times s to the power 5, so s to the 15. So your final answer here would be, I'm going to write it up here, 12 p cubed s to the power of 15. Okay, so you've got another set of things to do. Again, pause, think about how you set this out, set it out nice and clearly so you're dealing with each term in a row so that you can then connect your answer together. Okay, so pause now, and let's have a look at some answers. So the answers are on your screen now, so again, pause if you want to go through and look at them. If there's something that you've got wrong, I'll be back and have a look at the question. Can you work out why it was wrong? Was it a silly error? And then we'll, if not, circle it, we'll come back to it at the end. We need to begin building fractions. So all these rules that we've just developed, and we can summarize them. I'll summarize them for you in a minute. All these rules apply to any type of question. Whether there's fractions involved, meters involved, the rules don't change. So if we did a quick summary of our rules, first one is, remember, x to the power 0, always 1. Second rule, if you are timesing the same base, you add the powers. Third rule, if you are dividing, you subtract the powers. And fourth rule we just touched upon is bracket rule. Anything inside and outside bracket get multiplied. Okay, so there, that would be A times B. So these rules are not going to change, even though now we're going to be looking at some more complicated problems. So let's start with an example. So E, I'm going to give you one similar one to C. If I had x to the power of 1/3 times x to the power of 1/2. Okay, so the rules apply, but you've got the same base here, x and x. So you can use rule number 2 and say, well, all I need to do is add by powers, which means that all I need to do is 1/3 add half. And now it's going down to basic fractions. Can you add fractions? I cannot add fractions until I've had the same denominator. So for adding fractions, you need to have the same denominator. The same denominator. So I need a denominator that's in the 3 times table and the 2 times table. So it's been the 3 times table and in the 2 times table. So hopefully we can think of a number quite nice and easily. Well, 6 is in the 3 times table and it's in the 2 times table. So this one's going to get times 2, and this one's going to get times by 3, so that I can have fraction 1 over 3 is the same as 2 over 6. Plus a half is the same as 3 over 6. So by rewriting this, I haven't made the fraction bigger any smaller, I've just rewritten it in a way that means I now have the same denominator, so I can add them. So now I can add across. So I can do the numerator, add the numerator, and the denominator, add the denominator. Which means that the answer up here is x to the power of 5 over 6. So all hasn't changed. I do exactly what I was doing before. And say again when we're looking, if we look at F, when you have a go at F, you've got 0.5 and minus 0.5. You've got decimals. The rules don't change. You can do your number times your number. So I'm going to do it up here. So I'm going to do 3 times 4 and work out what that is. And then I've got my x term and my x term. So I've got x to the 0.5 times x to the minus 0.5. Because you're multiplying at the same base, you're going to add the powers. So you're going to do 0.5 add minus 0.5 and find your answer. So hopefully we should get a 12 here, and here we should get x to the power of 0. So we get 12 x to the power of 0. And remember what we said about x to the power of 0, it's our number 1 rule. That becomes a 1, so this just becomes a 12. So these are more challenging problems, but there's no new knowledge that you need. It's just about combining different topics together. Okay, so have a look at these questions. I want you to have a go at them. So pause your video now. Now welcome back. So we're going to have a look at the answers to these. And this is going to be a really important set of answers to look at. So if you get the question wrong, it's going to be really important you go back over and you look at your fundamentals and you work out what was it that meant that you didn't understand it. Was it adding fractions? Was there a negative involved? Was it that the subtraction didn't work? And you go back over it. And then if you're still stuck on it, you need to contact me and we're going to go through it together, because there is nothing more important than being able to do the fundamental fraction negative work. Okay, so here are your answers down here to go through. So pause now if you want to just go through those answers. Otherwise, we're going to move on. Okay. That is the end of the lesson. So that is bringing everything together. That is using your 3 rules and making sure that you've really, really understood how they're used in different contexts, and finishing with these more complicated questions. This is an important time for you now to, number 1, go back to the start and go back and have a look at, I'm going to zoom through it, go back and have a look at those first questions I asked you to do. And I want any one of those that you got wrong, I want you to go back over now and think, okay, well, could I do this question now? If that's a yes, that's great, you've resolved it. If not, you need to get in contact, okay? And we're going to do this on a one-to-one level. So if you really, really are still lost at any of these, or on that last question, you're still not sure about it, any of these, get in contact. So my email address is on the screen now. Okay, it's really important because this is now your transition to year 11. This is now your final year. This is us building you, preparing you for your GCSEs. And there is nothing that you can't do. So drop me an email. We will go through it together. We can make sure we resolved it. If you're happy, if you've gone through those and you understand it, that's brilliant. It's now time for you to go and demonstrate your knowledge and get on with some homework. So reminder, put the homework back on the screen. You need to be doing today clips 105, 106, 107. There will be more clips set tomorrow and the day after, so don't let this kind of creep up and build up on you for Thursday. It's due on Thursday, and you need to make sure that you're getting a pass rate of above 90%. So if you're trying it and you're not getting those levels and you've tried a good 3-4 times, again, get in contact and let me help you through this so we can make sure that you've really, really understood this topic. Thank you very much for working hard. Hopefully you found this really useful and you've got some excellent notes that you can now write up nice and neat and get those key rules down for indices. Thanks very much, Year 10. Bye.